Okay, so let's continue with electronic configuration. So in the previous section, we have already discussed about shells, subshells, orbitals and all. So in this section, we will see how to write the electronic configuration. So majorly, we will discuss about how we are going to write and what all rules and principles which we have to follow in this section. So, okay, so let's continue. So when we talk about electronic configuration, actually it gives an information. Now, when we say it gives an information, so what kind of information? So it gives information about the number of electrons, right? So when I'm saying number of electrons, now where? This is very important. So it gives information about the number of electrons in each shell, subshell and orbitals. Of an atom. And when we fill the electrons, as I mentioned earlier, we have to fill in order of increasing energy. So the subshells are filled in order of increasing energy, right? So let's say if I am writing here, take an example. If I'm writing 1s1, what it means. So 1 signifies or represent principal quantum number, right? S gives the subshell information, and this 1 gives an idea of how many number of electrons are there, right? So this is how we can find out. So before going into the detail of the electronic configuration, let's imagine or let's discuss how electrons actually are. So you can imagine uh, electron as a spinning charge, let's say like this. Okay, this is the spinning charge, right? There is an axis on which these electrons are moving, right? So let's say I'm giving north and south. One is giving here like this, south and north. So electrons are moving in, let's say this electron is moving in clockwise direction. This is moving in anti-clockwise direction, right? So we have to imagine the electrons are simple spinning charge which rotates on their own axis in either a clockwise, so this is clockwise rotation and this is anti-clockwise rotation, right? So these clockwise and anti-clockwise rotation of the electrons are very important, and why it is important we will discuss soon in the coming section. So this is very important that the electrons, when they are revolving, the electron must rotate in clock as well as in anti-clockwise direction, right? So if imagine the electrons are moving in the same spinning, let's say, let's take an example that electrons are moving in the same spinning, then what the problem will be? The problem will be the repulsion, right? So electrons with the same spin repel each other. That is why one electron moves in clock, another moves in anti-clockwise each other, which is also called We can call them as a spin pair repulsion. Fine. So therefore electrons will occupy the separate orbitals in the same subshells first to minimize these repulsion. So let's say if let's say I have to put electron in p shell, right? So in p shell we have 3 orbitals, right? And let's say you want to put 3 electrons. So one you will put here, one will put here, and one you will put here. If you're going to put the electrons like this, let's say like this, there will be repulsion. This will lead to repulsion, which is not good. So this is not allowed. This is allowed, right? Because here you are putting in 3 different orbitals. That is why it is allowed. So I can say that therefore electrons will occupy separate orbitals in the same subshell. Why? First, to minimize this repulsion. And once repulsion is not there, so they will be in a stable condition and have their spin in same direction. Now later on, if you want, you can pair up. Let's say p have 4 electrons, then one will be like this. So now you can do the pairing, one clock and one anti-clockwise. So this is clock and this electron is anti-clock, right? So I can mention here that they will then pair up with a second electron being added to the first p orbital with its spin in opposite direction. And this is called Hund's rule. This is called Hund's rule. So according to Hund's rule, what we have to do? We have to fill the electrons in a parallel fashion first in each orbital, and then later on you can fill in anticlockwise. So let's say if there is 3 electrons in a p shell or p subshell, right? So it is like this. So as per this, one electron will go here, which is in px direction, another will go in py direction, another will go in pz direction. This is how the electrons will keep on moving, right? Now let's continue the next concept. So the principle quantum number indicates the number of energy level, also indicates the energy of the electron in that shell, right? So we can say that the principle quantum number indicates energy level of a particular shell, but also indicates the energy of the electron in that shell. So this is very important point. So even though there is a repulsion between negative charge electrons, they occupy the same region in the orbital, right? Because of this anti-clockwise and anti-clockwise direction orientation. So we can say even though there is repulsion between negatively charged electron, they occupy the same region of space in orbital, right? So in orbital can hold only 2 electrons, right? Not more than that. So this is very important, that an orbital can only hold 2 electrons, and they must have opposite spin, like this. If this is one orbital, let's say this is S, so one electron will go in clock, one will go in anti-clock, right? This is called Pauli Exclusion Principle. Right? So this is very important, that we should understand that this is required. Else the repulsion will happen and atom is not going to be exist in a stable condition. So I can say that why this is happening, what are the reason, you can mention that this is because the energy required to jump to a higher empty orbital is greater than the inner electron repulsion, right? So that's the reason. For this reason, they pair up and occupy the lower energy level first. So we can say for this reason, they pair up and occupy lower energy level first, right? So let's say, take an example. If I'm going to write an electronic configuration of, let's say, chlorine. So we will write 1s2, 2s2, 2p6, 3s2, 3p5. So chlorine is 17. We just add up and we'll see. So 5 plus 2, 7, 7 plus 11, 12, 13, 14, 15. We need, so it's 2 to 4, 10, 12, 15 plus 2, 17. Now how to write the orbital configuration? So we have to make a box. So there are two electrons, so one clockwise, one anti-clockwise. One clock, one anti-clock. So one clock, first we'll fill like this, and then we will fill anti-clock like this. For 3s, we will show it like this. For 3p, there are 5 electrons, so first we will fill it like this. 1, 2, 3, 4, 5, like this. So this is how the electronic configuration is done. So in the next lesson, we will see the electronic configuration of the first 1 to 30 elements, and we'll discuss more about it. Till now, that's it. Thank you, and see you in the next lecture.